Today we're going to solve this difficult question from GMAT Club, and the question is not that difficult if you understand one formula or one method, which is how to calculate the number of factors of an integer. If you know that method, then this problem becomes fairly easy and straightforward. So that's the first thing we are going to do, and then we'll dive into the problem. So let's assume x is prime factorized into these prime factors a, b, c, d, where powers of the prime factors are p, q, r, and s, and so on. And the formula for number of factors of x is simply the product of 1 plus the powers of the prime factors, which is p plus 1 multiplied by q plus 1 multiplied by r plus 1 multiplied by s plus 1, and so on. So what does that imply? That implies that to calculate the number of factors of any number, I need to know not really which prime factors are there in the number, but the fact that there are prime factors in the number and also the power of those prime factors. If I do not know the powers of the prime factors clearly, then I cannot solve the question. All right, so now let's jump into the solution of this question. Here we have to find the number of factors of 10p, which I can also write as 5 multiplied by 2 multiplied by p. However, we don't know what p is. So p could have prime factors which are 5 and 2. That means that when you do actual prime factorization of 10p, you may end up getting different powers for 5 and 2. Or it could be a number that does not have 5 and 2 as prime numbers, or a combination of these scenarios. So it is not straightforward to apply the number of factors formula to get to an answer here. All right, so we are definitely missing some data, and let's see if any of these statements is actually providing us that data. So in statement 1, we are given that p is a total of 3 positive factors. It is a known fact that a square of a prime number has 3 positive factors. How do we know that? Simple, by number of factors formula. If you have x equal to a square, then 2 plus 1 would be 3. Because there are no other prime factors, this is the only number that you're going to add with 1 and get the number of factors. If x equals a multiplied by b, let's assume, right? Then the factor would become 1 plus 1 multiplied by 1 plus 1, and it will become, number of factors would become 4. So what is given to me in statement 1 is that p is a prime number squared, or p is a square of a prime number. However, it doesn't tell me whether it is 5 or 2 or some other prime number. And what that means is, if it were 5 or 2, then the answer would be different as opposed to if it were 3 square, right? So let's just write it down. Let's assume it was 5 square, right? So that is 5 multiplied by 2 multiplied by 5 square. So that is 2 multiplied by 5 to the power of 3, and the number of prime factors here is 1 plus 1 into 3 plus 1 equals 8. However, if it were a different prime number, for example 5 multiplied by 2 multiplied by, let's say, 3 squared, then you would get 1 plus 1 multiplied by 1 plus 1 multiplied by 2 plus 1, total number of factors as 12. So the data is definitely insufficient. Now let's take statement 2. In statement 2, we are given that the greatest common factor of 10 and p is 1. However, again, we don't know what p is, right? P could be any number of factors. We don't know what the prime factorization of p is, and without knowing exactly what the prime factorization of p is, we can't know the answer. We know we have a 5 and 2 in 10, and we know that p does not have 5 and 2, but p could have 3 to any power, 7 to any power, 17 to any power, any number. So we cannot calculate the number of factors of 10p. Hence, this is clearly insufficient. When you combine these two sentences, however, you know that p is a square of a prime number, and also it does not have 5 and 2 in it because the HCF, or the greatest common factor, is 1. So what that ends up is 10p would be equal to 5 multiplied by 2, some prime number a squared, because we know it's a square of a prime number, and a cannot have 5 or 2 in it. We have a clear answer that the number of prime factors would be 12, which is 1 plus 1 multiplied by 1 plus 1 multiplied by 2 plus 1. Hence, the answer to this problem is C. Both statements, when combined, can answer the question. I hope this helped. If you have any doubts, please comment on my YouTube. I personally respond to all the questions. Thank you. All the best with your prep.